Hey everybody, welcome to our social justice math class again. We are starting our final unit here, one that deals with apportionment and the concept of gerrymandering. So today's lesson is going to be pretty short. We are going to go over some very basics on how we actually apportion things. We're going to pretty much stick to the terminology of apportioning seats. The good example of this would be the House of Representatives in the US. So it's going to kind of be our main example here because that's really where a lot of the gerrymandering talk is going to come from. But let's just take a look generally at how we might do something like this. So before we start, right, if you were in my class, then what I'd ask you to do is take a look at the worksheet for this lesson, right? There is a front page and then a smidge of the back as well that is going to have some questions on there, and it's going to walk you through some of the things we're about to talk about in a much more organic way. So I want you to try that first before we've discussed anything. So if you would go ahead and pause here, complete that worksheet, at least the first part. There will be a break there that tells you when to come back to the slides. And then think about that for a while, come back here, and then we'll talk a little bit more about it. All right. Well, hopefully the worksheet has gone well if you've done it. Uh, if not, then you know what I just said. But if you have, then let's look at some actual definitions for apportionment. Right. What we are doing is we are dividing up and assigning things based on a proportional basis. Right. So assigning something with some sort of respect to the proportions that certain things have of the whole. So we will generally use, right, seats and apportion those to states based on their population, but we can, look at different things here in the worksheet. I believe it's nurses, right, to shifts based on the number of patients, right? So anything like that, there's a lot of different applications for it, but we'll stick to mainly the political one just so we have some terminology that's consistent. So we're going to be dividing up seats to the different states. And then our proportional basis comes from the population. So based on how much of the population share they have. So yeah, here's our hospital example, right? We have the seats, which are the nurses that we're trying to divvy up into the four shifts based on the average number of patients that would be seen during each shift. All right, so we've seen a couple terms on the worksheet so far. The first one is standard divisor. This is going to kind of be our measuring stick for apportionment. And the way we find our standard divisor is we just take the total population and we divide it by the number of seats. And what that does is it tells us how many people in the population is equivalent to one seat, right? If we have a certain number of seats to divvy up, how can we actually divvy them up, right? How many people we need to have in a state so they get one seat? How many more people we need to have so they get another seat? That kind of thing. Then what we're going to do is we're going to use that to find the state's standard quota, right? This is the number of seats that each state would get if we were able to have fractional seats. Now, obviously, we're not able to say, well, Mississippi, you get 13.3 seats. So, figure out what to do with that 0.3, right? That's not a realistic thing. So we're going to have to find some way to deal with that. But this is a starting point where we would just find how many seats would be allowed if we were allowed those fractions. So we're going to take the state's population and just divide it by our standard divisor here, right? So figure out how many seats each one would get. So now we have to address that question, right? What do we do with the leftover pieces? What do we do with the fractions? What do we do with the decimals? Well, we could round down, right? And if we do that, right, just every time we get a standard quota, we just round down immediately. We call that the lower quota. We could round up, in which case we would get what we call the upper quota. So literally just everything round up, right? And then this is, I'm talking like 12.2 rounds up to 13 in this case for the upper quota, or even something like rounding down. If we have 7.9, that would round down to 7, right? So this is a hard and fast. This is not our standard rules. Now we could use our standard rules, right? If our fraction is 0.5 or above, right, then we would go ahead and round up. If it's lower than that, we would round down. But the main problem here is none of these fully guarantee that the number of seats we're going to give out is going to stay consistent, right? And you saw this on the worksheet as well when we tried to deal with the number of nurses. But we can get some insight as to what we want to do here, right? And that is, right, no state should receive less seats than its lower quota, and it shouldn't receive more seats than its upper quota, right? So these are really our two choices that we have here, right? Do we round down? Do we round up? And how do we do that in a way where we actually hit the number of seats that we want, right? Where the number of seats doesn't fluctuate. Well, this is not a new problem, right? This has been the way things have been apportioned in the US for since the start, right? So we want to look at some of the methods used historically, and maybe we can glean some insight from that. So first, we had what we call the Jefferson method, which was just round down no matter what, right? You get your standard quota, round it down, everybody gets their lower quota. Now, when this happened, the total number of seats in the House of Representatives would fluctuate, right? Depending on how that rounding went exactly. So there may be times where there were two more seats, two less seats, something like that, right? So on top of this, right, if you had a standard quota that was really, really close to the next number, right, imagine how you'd feel if you had to round that down and you essentially lost out on a share of the house that you should have otherwise had. And say, okay, well, let's do something a little different. So the Webster method just used traditional rounding, right? Now the numbers still fluctuated, but at least this meant that if you had a really high decimal number there, if you had a really high fractional part for your standard quota, you would at least round up and you would get that extra seat, right? So it fixed one of the problems, but not really the other. Well, then we went to the Hamilton method, right? And what we did was we provided each state with its lower quota. So we divvied all those up first. And then we took however many seats we had left and just gave those out to the largest fractional parts, right? So let's say we had, a state with a standard quota of this 14.999, and then we had another one with a standard quota of 14.5, and we had one extra surplus seat, we would give that one to the 14.999, right? So what this does is it just rewards the states that have the highest fractional part in their standard quota. And because we're doing this with the surplus seats, this number of seats isn't going to fluctuate, but where the cutoff is definitely going to fluctuate. Now, what we actually do today, in some sense, is similar to the Webster method, but where we round is a little different. So we actually use this formula here, right? Square root of the lower quota times the lower quota plus one minus the lower quota. And if that fractional part for our standard quota is bigger than that, then we round up. If not, then we round down. So this actually works out pretty well. I'm going to tell you for the next couple lessons, we're going to primarily focus on the Hamilton method because you end up getting fairly close, if not the same result between these two. But the Hamilton method is going to be much easier to deal with. So with that in mind, next time we will take a closer look at this apportionment. We'll talk about how we apportion things, and we'll also try and do some examples to see if we can get into the nitty-gritty of how the system works. So until next time, thank you for your time.